Hi, this is Captain Steve Tarrant from Maine Maritime Academy, and in this video we're going to be looking at doing some solutions to a trim problem. So let's say for those of you who are taking NS 301, this is actually problem 5 on the in-class worksheet. Say you have a vessel and you're limited to a maximum draft of 2603 feet. You can see from our initial drafts, 2104 and 2406 aft, that we're going to need to actually load the vessel in order to get down to our final draft. However, we also need to have a 12-inch drag when we finish this. So we have to figure out how much weight to put on the vessel and where to put it. Well, essentially, what that's actually going to look like is we'll put weight on the vessel somewhere forward. That'll drive the vessel down. Okay, that'll increase the mean draft, but at the same time, by putting it forward, we'll also change the trim. Okay. Now we could put that. And our task now is to figure out how much weight and how much forward the tipping center. Whether we put it on deck or tween decks or down on the bottom of the ship, that doesn't really matter. But probably to make it easier, we could probably think about this problem by breaking it down into two steps. First step would be to load the vessel at the tipping center, okay, by putting the weight more or less above the tipping center, which is close to amidships, not exactly amidships in most cases. And then after we've gotten the vessel down to the mean draft that we want, then shifting the weight fore or aft, in this case forward, to get the trim that we want. So essentially, what we're going to do is we're going to break the problem into two steps. The first step is loading at the tipping center and figuring out how much weight we need to get something called parallel sinkage to make the vessel go down, sink in a parallel state. Okay, we're going to do that from the mean draft. And then after we've figured out how much weight will make the vessel sink in a parallel fashion, this parallel sinkage, then we can figure out how far to move that weight in order to change the draft to the desired trim. Okay, so this is essentially how we're going to do that. We're going to do this problem in 5 steps. Okay. First thing is we're going to have to calculate our parallel sinkage. Okay, and that would be sinking the vessel down to the final mean draft. And the parallel sinkage, and here's an abbreviation for it. This is just 2 parallel lines, so that represents parallel sink. The abbreviation parallel sinkage is the difference between the initial mean draft initial, and mean draft final. So that's going to be step 1. Step 2 is after we do that, we're going to have to go to the deadweight scale and extract moment to trim 1 inch and TPI. The TPI is what we're going to use to figure out how much weight we're going to use to sink the vessel. The MTI is what we're going to use to figure out how far forward or aft of the tipping center we're going to have to move that weight. So in order to get MTI, we're going to extract that value from the deadweight scale using the greater mean draft, whichever one that happens to be. And for the TPI, we're going to take the average of the mean drafts. Okay. Now I'm writing out these instructions for you and what we're going to be doing. They may not really mean anything to you right now, but they will by the end of the problem. So step 3, okay, would be to calculate the required weight. So we calculate how far we have to sink the vessel. We're going to get a value for tons per inch immersion in this step, and now we're going to combine those to figure out how much weight we should actually put on the vessel to send it down to the final mean draft. That formula is going to be weight equals TPI times parallel sinkage. After we do that, then we're going to want to calculate the required change in trim. Okay, so that's trim change. Okay, and that's total change of trim, required change of trim. Okay, however you want to say it. But I'm going to abbreviate that by trim change in trim is going to equal the difference between the initial trim and the final trim. Okay, so we're going to have to calculate those 2 values as well, and then use those to calculate this. The last step is we're going to have to figure out what distance we need to put that weight relative to the tipping center, also known as the longitudinal center of flotation, in order to get the trim that we want at the end. In this case, 12 inches of drag. Okay? So we're going to do each of those steps one by one, and let's begin that. So step 1, calculate parallel sinkage. According to our directions, we have to calculate the mean draft, the initial mean draft, and the final mean draft, and then get the difference between those. So what was our initial mean draft? Well, our forward draft initial was 2104 and aft was 2406. So 2104, 2406, the mean draft is 2211. So we've got the first term here. Now we need to get this term. Well, we look in here and say, well, where are the final drafts? Okay, well, we're going to have to combine the first line and this to actually figure that out. We are limited to a maximum draft of 2603, so we cannot exceed that. We need a 12-inch drag. That means the stern is going to be lower than the bow. That means that 2603 is going to be the stern draft. So our aft draft final, this should actually be a lowercase, a subscript, okay, like this. That should be after draft final is going to be 2603 feet. Well, if we're going to have a 12-inch drag, what would the forward final draft be? Well, if we're going to have 12-inch drag, it's going to be 1 foot less than that. So that should be 2503, and then we did that by inspection. So our mean draft final is going to be 2509. So this was our initial mean draft, 2211. Our final mean draft is 2509. We have to sink the vessel from 2211 to 2509. How many inches is that? Ignore that. How many inches is that? Well, turns out that that is 2 feet 10 inches. That's how we would sink the vessel in a parallel fashion to get down to that mean draft. That equates to 34 inches. So we have to sink the vessel 34 inches. Well, we're going to sink the vessel. How are we going to do that? We're going to add weight. Well, how much weight are we going to add? Now we need TPI. Okay? Since we're going in to get TPI, we might as well get MTI at the same time. So we're going to go to the deadweight scale. That's step 2. So let's grab our moment to trim 1 inch first. It says here, use the greater mean draft. Well, here are your two mean drafts. Mean draft initial, mean draft final. Which one is greater? This one. So we're going to go in at 2509. Here it is. Okay, 2509. And there is our moment to trim 1 inch. MTI is 1150. Now, this is kind of funny written English, but basically what it means is that take the halfway between the initial mean draft and the final mean draft. So what was our initial mean draft? 2211. There's 22. There's 11. What is our final mean draft? 2509. There's the line. Okay. Well, what we want to do is we want to go halfway between them. Well, halfway is about right here. And our TPI is going to be 49.2 tons per inch. All right. So we took MTI from the maximum draft, but we took TPI from the average of the two. Okay. So there we have that. So now we're going to do step 3. Calculate the required weight to create the parallel sinkage. Well, our parallel sinkage from step 1 is 34 inches. If we're going to sink 34 inches, we need 49 tons per inch. So we're going to multiply these two. TPI times parallel sinkage. That's 49.2 times 34. We're going to have to put 1,673 tons onto the vessel. And if we put that right here, we'll sink the vessel in a parallel way. Okay? And that's step 1. The next step then is, now that we've got the vessel down, now we want to adjust the trim. So now we have to slide it forward or aft, in this case forward, and that will change our trim. So let's do that. The trim change is going to equal the initial trim minus the final trim, or the final trim minus the initial trim. Just put the bigger one first so that you don't end up with a negative number. So our forward initial draft was 2104, our aft was 2406. What was our initial trim? Trim initial is 38 inches. Well, it tells us right here what our final trim is going to be. It's got to be 12 inches. So what's our trim final? Okay, 12. So we're going to subtract 12 from 38, and our trim change is going to be 26 inches. Okay, so if we load 1,673 tons at a midships, we'll sink the boat down to the proper mean draft. But now the stern, was too deep. We have to we have to shift some weight forward to decrease the stern draft and increase the bow draft so that we can get to a drag of 12 inches. So we're going to do that using this last formula, figure out the distance. The change of trim, or the trim change, equals the trimming moment divided by MTI. Well, it turns out that trimming moment can be broken down into two variables. Any moment is a weight times a distance. So the change in trim is going to equal the weight times the distance divided by MTI. Well, trim change, we have. It's 26 inches. Weight, we have. It's 1,673 tons. MTI, we have. It's 1150. The only thing we don't have is distance. So what are we going to do? We're going to rearrange this formula. We're going to solve for D. So we'll multiply both sides by MTI. We'll divide by W. Okay? And we get distance equals trim change times MTI divided by weight. Well, now we substitute. 26, 1150, 1673, and voila, our distance is 17.9 feet, and it's got to be forward of the tipping center. Okay, and that's how you do that problem. Thanks.